All right, today we're covering Pythagorean Theorem. We use Pythagorean Theorem with right triangles only. If you look at the triangle, the two sides that surround, that are next to the 90-degree angle are called the legs. And the side opposite is called a hypotenuse, the side opposite the 90-degree angle. The hypotenuse is also always the largest side. So if they just give you the numbers, we know that the biggest number goes with the hypotenuse. Now, a lot of times we name these A, B, and C, but I want you to be, for middle school purposes, we'll use A, B, and C, and the formula A squared plus B squared equals C squared to refer to Pythagorean Theorem. Know that A and B are interchangeable, so I could call one A and the other B, but C is always the hypotenuse, okay? Or the longest part is always the hypotenuse. I once knew a calculus teacher that rearranged the variables and called the legs A and C, and the B was the hypotenuse. So pay attention to that. Always know your hypotenuse is opposite the 90-degree angle. And the formula works like this. So let's practice one. If I have, what would I substitute for A? Hike?
6 or 8.
6. And then for the B, we'll substitute 8. And our C is going to stay X. Now, we have to simplify. We are not allowed to add 6 and 8 and then square, because the rule of exponent says you can only put them together if they have a like base. They're not like bases. So we have to do 6 squared is 36. 8 squared is 64. When we add them together, we get 100 equals x squared. You should be writing this. Now, what do I do at this point? Daryush? Good. We're going to take the square, we're going to root both sides. And the square root of 100 is 10. And the square root of x squared is the absolute value of x. To lose the absolute value, what do we have to do? David?
X equals plus minus 10.
However, because we are doing Pythagorean Theorem, because it is measurement, one of these is an extraneous solution. Which one is that, Caleb?
The negative.
Yeah, distance can't be negative. So, it becomes, now, I suppose you can skip that end of it, but if you're doing the square root method, I want to see that every other time, outside of Pythagorean Theorem. Yes?
Couldn't you just use the zero product property? You would get the same answer.
Yeah, but I want you to be able to have more than one method. So you guys try the next one, go. Shh. Stop making noises. Who's doing that? Jack, what are you doing? Huh? Why is your head down on your arm? All right, let's check our work. We substitute 7 squared and 4 squared, 49 plus 16, and we get 65. Now we root both sides, and we get y is equal to the square root of 65. Now, I would like to see you try and reduce your radicals as well as estimate. Is this a reduced radical, or do we need to simplify it more?
Estimate.
So, square root of 65 is fine. There's no simplifying it. To estimate it, my closest perfect square is 64. What would you estimate this at? 8.1. Good. So it's about, and notice every time we say we estimate, we use the about sign. But But radical 65 is as simplified as it gets. I want you to practice both for homework. All right, in this situation, what's different? Josh?
The hypotenuse is labeled rather than years.
They're giving us the hypotenuse. So make sure you're substituting accurately. 15, the hypotenuse goes in for c squared. Then we simplify it. Subtract 36. And now root it. If I were going to simplify the radical 189, what is it divisible by?
9.
9 times what?
9 times 21.
9 times 21. So what radical would that reduce to?
3 rad 21.
3 rad 21. And if I want to estimate it, 189 is between what numbers? Jack?
169 and 196.
Yep. Is it closer to 169 or 196? Okay, it's 20 digits from 169 and it's 7 digits from 196. So what's your best guess? Hike?
Like 13.7.
Perfect. Look at that. He guessed perfect. If you had guessed 13.8, I would have taken it. Questions? Yes.
In this. Oh, never mind.
All right. Another. Yes.
Why do you have the 3 rad 21 and the 13.7?
Because I just said I want you to try both. Okay. Yeah.
For the homework, do you have to draw the triangle?
You should. Determine whether the given lengths could be the sides of a right triangle. If they're asking you if this is a right triangle, it should work with Pythagorean theorem. So I write up my Pythagorean theorem, and then I substitute in. Okay? And if they're equivalent, then it is a right triangle. So 25 plus 144 is 169. Are they equivalent? If they're equivalent, it's a right triangle. Yes, it's a right triangle. Yes, question.
How do you know which one is a hypotenuse?
How do you know which is the hypotenuse? Who can answer that question? What?
Me or you?
Deja? It's okay. It looked like I was pointing to both of you. Okay.
Well, since it's the longer side, it's a larger number.
It's the largest number. So when I substitute in here, notice they threw us for a loop. They didn't give it to you in order. You have to put the 12 in for the C. And then when we simplify it, are they equivalent?
No.
So is this a right triangle? No. If it's not equivalent, it's not a right triangle. Questions? Okay, Pythagorean triples. I don't use these a lot. I don't want you using them, but you should know them. They come up in standardized testing and it saves you time. A Pythagorean triple is where like 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, 9 and 16 equal 25, and 5 squared equals 25. Does that make sense? If I take, anytime you see a 3, 4, 5, that is a Pythagorean triple. If I double those numbers, that too will be a Pythagorean triple. If I triple those original numbers, still a Pythagorean triple. Quadruple, 4 times 3, 4 times 4, 4 times 5. All these numbers are right triangles. Okay? So all you really need to do is memorize those 3.
3, 4, 5, that's it.
Well, there's two other, there's more Pythagorean triples. Here's another, 5, 12, 13. Okay, if you double those, because everything else is a multiple of that. And then another one is 7, 24, and 25. I do still want you to do the math tonight. Be careful when they give you, like if they give you 2 legs and one is 3 and one is 5, people want to put 4 for the hypotenuse. That's the way they trick you. Yes?
What about if you do Pythagorean triple even if it's not a perfect, even if it's not a right
Could you what?
Could you do Pythagorean triple even if it's not a perfect right triangle?
No, it only works for right triangles. No. All right. We're gonna pause. We're gonna skip this for now, and I want to show you. We'll do the proof later. We're gonna spend a day doing the proof. And now I want to actually show you. You're gonna get some homework tonight with radicals. So if you look at number 18 and tonight's homework, they give you, what they do is they give you A is equal to 3 radical 3. And C is equal to 5 radical 3. They said, find the length of the side that's not given for a right triangle with hypotenuse C and legs AB. So I'm using my Pythagorean theorem. Here's A, here's B, here's C. The B, we said we don't know what it is. The A is 3 radical 3, and the C is 5 radical 3. So I use my A squared plus B squared equals C squared. A squared is what? 3 radical 3 squared plus B squared equals okay, and we get, when I square 3 rad 3, what do we get? Yes. Or 9 times 3. You guys with me? Yes or no? When you square 5, what do you get? 25. And the square, when you square radical 3? 3. So that's where he gets the 27 plus B squared equals 75. Subtract 27. B squared equals 48. Now we can root them. What perfect square is in 48? Right. 16 times 3. So B is equal to 4 rad 3. Now, we could estimate that. I could have estimated here or here. 48 is very close to 49. So it's like 6.9. Okay, questions? All right, now for the distance formula. I'm going to explain where it comes from. You don't have to write this part of it down. Yes?
I have questions about the right triangles. When you find that on the board, do you want us to write the formula down every time? A squared plus B squared plus
Okay. Okay, the distance formula. The distance formula gives us a formula that we want to find. We have a couple different ways we can do this. We can find the distance of that line if I create a triangle, right? I can find the distance of any line by creating a right angle. Count this. 1, 2, 3, 4, 5, 6. Count this. 1, 2, 3, 4. Okay? And use our Pythagorean theorem. So A6 squared plus 4 squared equals D squared. But another thing that we can use is this distance formula. And another way to look at how I get that 6 is, can I take the measurement of this y and subtract out the difference? Find the difference of this y. What does that equal?
6.
Well, 6. And I can also find the difference in my x's. from 1x to the next. 3 minus negative 1, 4. Okay? Well, if I substitute those in, isn't that the same thing we said as A, and this is the same thing as B? And then I can simplify it. 36 plus 16. Take the square root of both sides. And D is the square root of 52. A little bit more than 7. 7.2, 7.3, probably 7.2. All right. Well, if I take, you with me? If I take, instead of using those numbers, let's use the variables. Let's call this point 1 and this point 2. To find this distance, what did I find? I found the difference in my y's, right? And this is the difference in my x's. x2 minus x1. If this equals my a, I can substitute that in for a squared, and this in for b squared, and this in for c squared. Are you with me? Yes or no? Yes. So now, I like all that, but it's giving me d squared, and I want d. So how could I find d? Yep. Yeah, we're going to root both sides. And therein is our distance formula. Distance is equal to the square root, the difference of the x's squared, plus the difference of the y's squared. So let's try it. This formula, I want you to write it. I gave you 3 problems. You write it each time. What's x2? Come on, guys. What's x2? 3 minus negative 1. 4 minus negative 2. And then we just simplify inside. That's 4 squared plus 6 squared. 4 squared is what? And this is 36. Add them together. Square root of 52. 52 is a little more than 7 squared, so that's 7.2. That was pretty good. Yeah.
How do you know, like, which one goes in, like...
It doesn't matter. You name, just like when we're doing slope.
How do you do reverse them?
Huh?
Like, instead of putting 3 minus 1.
Well, let's try it. The formula is, you must use the formula. I'm going to, let's stop. Let's do this. I'm going to call this x1, stop, freeze. x1, y1. x2, y2. So I'm doing 6 minus negative 4 squared plus negative 2 minus 5 squared. 6 minus negative 4 is 10 squared. Hold on. I don't want to hear a chair move. And then we have negative 7 squared. Okay, D equals 100 plus 49. D equals the square root of 149. 13, it's a little more than 12. D is about equal to 12.2. You understand?